in the end of these rollers are an actual hex head opening that your wrench fits in, and all you do is put that wrench in and tension this down. Simply by pushing the Allen wrench away from you so that it rotates that roller that we've locked the mesh in with, that's already starting to put a certain amount of tension on. You'll notice that I only had it click about 3 or 4 times. That clicking sound that you hear is a ratchet system, which they have built into this stretcher so that it can actually hold its position after we go ahead and rotate the roller to be able to let us proceed over to the other side. So there's 1 click, 2 clicks, 3 clicks, 4 clicks. We're just going to start out right now without a lot of tension, because we can come back and distribute load bit by bit. Once again, kind of like the lug nuts on your car. So we put 2 to 4 clicks on each of the short sides. We're going to do the same thing on the long sides. And this is already putting a tension load onto that screen. So after our initial tensioning, where we did 2 to 4 clicks on each of the 4 sides, we've already built up a certain amount of tension on our screen surface. But likewise, since we made that cross of tension to start, most of our tension sits in the middle, not as much out in the corners. This is a tension meter. It measures in newtons per square centimeter. And it's not really something you need to know, other than the industry accepted standards end up with recommendations, usually 20 to 30 newtons. It depends a lot on mesh count as well as the frame size. But rather than get into all of that, which is kind of screen stretching 102, you'll notice when I set this tension meter down onto the screen, the dial's showing up between 10 and 11. Now that's far below what we actually want it to be, but you'll notice when I start to move over to the outer corner, that tension drops considerably, down to where it's not even reading much, down to 0 or so. So that's actually a good thing, because as we're putting tension onto this screen mesh, once again, we don't want those corners to go up at a tension that's going to be at a faster rate of what's happening in the center, or everything will just rip on you. And we don't want to have to stop and redo it all, let alone the cost of the material that we've had. Once again, because that teardrop shaped rod is the same shape as the locking channel, but a little bit smaller, that allowed us to create the cross of tension, but it also allows us to do something else that's kind of unusual, in that if we think we messed up at some point and our corners are a little bit too tight, this one's kind of soft, this one's kind of soft, this one's actually a lot tighter than that one or that one, we can come in and slightly push down that locking rod and push down on the mesh surface with our fingertips and actually take out some of that locking that had been done. What's neat is this holds itself in the channel so tightly, by pushing that one spot, we've only softened this one little spot over on the corner and not lost any of the tension that we went through so hard to try to get in the center. So by pushing down on those 2 points, but not the middle, I just softened these 2 corners to where they're more like those 2. I'm going to do the same thing on this locking rod, and you can see how baggy that is now compared to the rest, the span across the frame side. But you'll notice that we didn't lose any of the tension in the middle. Now what this is going to permit us to do, after we've gone in and softened our corners, and this can do what a lot of the high-end pneumatic stretchers automatically do, but at a fraction of the cost. So we've enhanced our cross of tension to where we're still tight in the middle, but we've gone way softer out in the corners. So we can go back and revisit each of the stretcher bar sides, and we're going to go back and put 2 or 3 more clicks onto each one. And all we're doing is running that roller further into its channel, pulling up more tension, increasing it in the middle. But since we corner softened, we're not going to have it get so tight at those corners that they're going to rip on us. One other good thing to know, and getting back to that short rubber band versus the long rubber band, is when we're putting 2 or 3 clicks on each of the rollers, since this is a longer stretchable thread compared to this, you'll actually be able to put an extra click or 2 each time on the long end versus the short end, in that this is going to get tighter a lot faster. Now, so at that stage we've gone around twice, we soften the corners once, and you'll see that we're up at 22 newtons. Now if we really wanted to go for higher tensions, we'd repeat the process that we had done before, which is go in with our applicator card, go in and depress our corners again, because they've actually gotten tight. That time that we picked up the mesh tension, it not only gave us the tension we wanted in our print area, but it quickly picked up the tension in those areas where we even made it baggier, once again because those threads are so short. So for the intents of the length of this video, I'm not going to go ahead and soften the corners again and then put 2 to 3 clicks on each side, but at that stage we could take the screen mesh up to the high 20s to 30. Once again, in the industry, 20 to 30 is pretty much an accepted standard. We'll have another video that'll explain screen tension to a lot more detail and the benefits of higher tension versus low tension. But now that we've been able to get our screen mesh stretched up onto our frame, we're coming down the home stretch where we simply need to fasten the screen mesh onto the frame surface.